All right, so the first thing you want to do when you're graphing a quadratic in vertex form is you want to pull out the vertex. So my vertex for this, you pull out your h. So it's always the opposite because the formula is minus h if you look at that original formula. So it's going to be -5, but then your outside k value stays the same, so -1. So our vertex, it's like that inside number, but you switch its sign, and the outside number that stays the same. So that's your vertex. Our axis of symmetry, so I just always abbreviate that AOS, is x equals, and it's always the x value of your vertex. So whatever that first number of your vertex, that's going to be your, oh, you guys can't see my screen either. All right, but sorry about that. So hopefully now you can see, but sorry, our vertex is -5 and -1. So you pull the inside h number, but it switches the sign because of the formula, it's minus h. And then your k value is that outside coefficient. Just double check chat. Okay. Okay. All right. Don't know what the issue was. So when we do our table, we always put our vertex in the center. And honestly, I mean, unless you're just an overachiever, I mean, 7 points, come on, that's too much. 5 points is plenty. Unless you want to overachieve. I mean, you can get as many points as you want, but I mean, I don't know. It's pretty typical. The 2 points on both sides of your vertex is pretty standard. So I did not make these notes. Whoever made them, man, they are above and beyond me. But when you just add your x value, so you go 2 to the right, so you like add one, and you go 2 to the left of it. And you should always use the same interval. I mean, I'm always going to go up by 1 or down by 1, but you should always use the same interval because that lets us use the symmetry, so we can save some times, like so we don't have to plug in every number. So we're just going to plug in one number at a time. But remember, these two spots are going to be the same. So I don't need to really plug in both. If I plug in one, I know the answer to both. So they're both negative. Usually I try and avoid negatives if I can, but so I'm going to plug in -4. So -4 plus 5 squared minus 1. So if you work that out, you'd have -1 squared minus 1. That would just be 1 squared is 1. So -1 minus 1. That would be -2. You don't need to like work it out. I mean, if you're just plugging it in a calculator, that's totally fine. Just be careful when you plug it in, though. You might even want to put in piece by piece, or if you put in the whole thing, be careful with the parentheses. That can lead to a lot of mistakes with quadratics because remember, your calculator, if you're trying to square a negative number, like if you put in your, like, sorry, this is a little bit of a tangent, but oops, almost screwed up again. But if you put this in your calculator, it's going to give you the wrong answer. It's going to give you this. You got to put parentheses around it because -5 times -5 should be +25. So it's really important when you're like plugging these in to get your points that you put those parentheses around it, or you will get wrong answers, especially when you're plugging in negatives. Okay, but we'll plug in -3 next. So depending on how good you are with your mental math, or you could just plug it in like it looks, but you would get 2 squared on the inside. Oops, what am I writing? -1. So that would be 2 squared is 4. So that negative, that would make it a -4. -1, that would be -5. So since it's symmetric, those two y values are going to be the same. Or if you don't believe me, or you like plugging in numbers, you could plug in -7 in as well, and you'd see you get that same answer. But parabolas are always symmetric, like equal distance on both sides of the vertex are going to give you the same y values. So we're just going to quickly plot this. So -5, -1, I always start with the vertex. And I like to plot like one number on both sides. So like -4, -2 would be here. -6, -2 would be here because they're like symmetrical. See, a lot of people disconnected. Here, let me just pause this really quick. Recording. All right. Sorry about that. So then we're going to plot -3, -5. That would be down here. We just kind of, oops. that would be 2, 3, 4, 5. So that would be here. And then the 3, -5 would be here, or -3, -5, sorry, would be here. So if you draw it, it's going to look something roughly like this. So one thing I wanted us to do is just to kind of get in that habit is make sure we see if we can write the domain and range of our graph. So the domain is honestly no thinking required. For any quadratic, it's always going to be all real numbers because your graph is going to go to the left forever and it's going to go to the right forever. No matter how you modify it, like it's either going to open up and up to the left and right, or it's going to open down to the left and right. So it will always include all x values. Like it'll hit every x value if you kept drawing it forever. The range is going to change on the problem. So you could use interval notation, but you want to think about like the lowest your graph go. If you do interval notation, you want to think how low does it go and then how high does it go. So the lowest it would go is negative infinity. God, I'm like cold. So it's like I'm like writing like a 2-year-old today. Usually I write like a 4-year-old. All right, but negative infinity to -1. Or if you like it, I've been trying to show you too, you can also write it with inequalities. It would be y is less than or equal to -1. Like basically it's everything smaller than -1 for our y value. So either way is acceptable. So I know we first learned interval notation, but if you prefer the inequalities, I mean, I'm good with either way. All right, well, so that's it for question 10. Let's look at question 11 really quick. So the first thing we want to do is pull out our vertex. So, I mean, it would be 4, 0, because this is your h, and then our k is really +0 if there's nothing out there. So that means our axis of symmetry would just be x equals 4. And I didn't draw the axis of symmetry because honestly, usually I don't, but like for this problem, like x equals -5, it's just like a vertical line that your graph would basically fold on. Oh, and sorry, Aslan, I just saw your question. So she asked how I got this -1. I'm guessing for the range here, right? So if you're thinking of interval notation, like it goes from negative infinity up to like -1's the highest it goes on our y-axis. Oh, I just realized I was like covering it with my mouse. You can't see that. Like on our y-axis, like the highest our graph goes is here at -1. So if you use an interval notation, oh, it should be a bracket. You're right. Yes. So yes, it should be a bracket. My mistake. So that's probably why you're confused. So you were probably more right than I was. So yes, sorry, that should be a bracket if you're using an interval notation because it is included. And I apologize if anyone is watching this video later. I feel like I'm jumping all over the place. All right, well let's go back to question 11. But good questions though, honestly. It's my bad, not your bad. So we got our vertex, so we're going to put that in the middle of our table. So we're going to not worry about these. So we're just going to go 2 to the right, so 5 and 6. 2 to the left of our vertex would be 3 and 2. Always excited when I have positive numbers because I don't have to worry too much about signs, hopefully. I guess it depends, actually. We could, depending on if we are subtracting. All right, so I'm going to plug in the bigger numbers because I notice I won't get negative. So I'm going to plug in 5. And you do not have to show your work. I'm just writing it for illustration purposes here. But if you work that out, 5 minus 4 would be 1. 1 squared would be 1. So 3 times 1 really is 3. Okay, let me zoom in and try and rewrite that. Based on symmetry, remember, that means this answer is going to be the same. But if you don't believe me, you could always plug it in. So then we're going to do the same thing. We're going to plug in 6, though. So 6 minus 4 would be 2. 2 squared is 4. So 3 times 4 would be 12. So this is not going to fit on our graph. So we'll probably just plot these 3 middle points. But my vertex would be at 4, 0. My other 2 points that fit, I have 5, 3, and I have 3, 3. And you could see that like that's pretty bad, but it's growing really fast. Like those next points would be off the graph. So it's a really, since that 3, it's a vertical stretch. It's stretched it up. So that makes our graph look like really skinny because it grows super fast. It doesn't have a chance to get like wide on our graph. So our domain, like I said, for every single one of these, it's all real numbers because your graph goes to the left and right forever. Our range would be like the lowest it goes is 0. So you could do 0 to positive infinity. Or if you want to do an inequality, it would be y, because it's range. So y is greater than or equal to 0. So if the inequalities, I know some people with the interval notation, it was a little bit rough. If the inequalities is like, I don't know, it's your bread and butter, it's making more sense kind of thing, use those. Or if you copied it, like if you already looked on like the key, that's fine. Like I said, you're not gonna have to be able to do any problems like that. I'm gonna skip that for right now. But I do want to look at this problem. This problem, we're basically working backwards. We're gonna try and write an equation in vertex form when we're given a graph. So this is how you'd want to approach it if you're kind of working backwards. Well, remember, our h and our k are our vertex. So the first thing we want to do is pull out our vertex. So if you just look at your graph, our vertex appears to be at 1, 6, right? Let me just make sure the numbers are above the line they're supposed to be, right? Let me just count 1, 2, 3, 4, 5, 6, 7. Oh, it's actually 7. Okay. Those numbers are a little bit deceiving then. All right, so our vertex is 1, 7, though, if you count like the grids. So when we plug it in, and we're going to have y equals, we're going to worry about the a next. So I'm just going to plug in what we do. But x minus h, remember our vertex goes h comma k. So it'd be minus 1 squared plus 7. But we got to figure out our a. That's what we kind of need to look for. So here's how you want to get your a value. First is you want to see, did it reflect? If you look at this parabola, see it's opening down. So right away, I know my a is negative. So my question is, though, is it stretched at all or is it compressed at all? So here's an easy way you can check. From your vertex, and I'm just going to zoom in a lot so I can actually maybe write so you can see. You just want to see like almost it's not really your slope because it's not like a line, but you want to see like what was the rate of change for, like you want to find your first, oops, I'm like erasing and screwing everything up. All right. But if you see like our first nice point is here, like it goes down 2 to the right 2 before we get to our first point. Like 1 unit over, it goes down 2. So a normal parabola, like if you looked at our parent function, I don't know if I have that graph nicely, but like this is our parent function. Like if you look at it, usually like our original graph goes like for 1 unit to the right, it goes up 1. So that means that this graph was stretched. Like since it like 1 unit to the right, it went down 2. That would mean it's stretched by 2. So our value wouldn't be -1, it would be -2. So basically to find your a value, you first, I mean, if it reflected, it's going to be negative, but you want to see like if you go 1 unit to the right, what was your y value change? In this problem, it went down 2. So that's why it's -2. It went down 2. But that's kind of the idea with this if you are working backwards. You won't see any questions like this on the assignment, but I do think this is maybe a skill that should be something. I mean, if you can work forward, hopefully you can work backwards kind of thing. Any questions about this graphing one though?